Here's a question I get asked actually quite a bit. It's, what resolution do I need my images to be? And to be able to answer that question, you first have to figure out, where are you sending these images? What's your output path for these? Are they going to be printed? If so, are they going to be printed on a printing press, or are they going to be printed to your inkjet printer on your desktop? Or are they going to be displayed on a screen of some sort, whether it be a monitor or a cell phone or tablet device or a netbook, or you name it, anything with a digital display? So 3 different categories of output. There's halftone output, there's continuous tone output, and there's display output. Let's talk about each one of those, because each one of them has different resolution needs. So let's talk about halftone output first. Halftone output is the word that's used when you are reproducing images on a printing press. There really is no notion of continuous tone on a printing press. You're creating the illusion of continuous tone by using different series of dots of ink on paper. And typically in full color printing, there's CMYK color printing, there's cyan ink, magenta ink, yellow ink, and black ink. And there's 4 different dot patterns, each of a color ink, that when they're all laid and printed on top of each other, make up the illusion of a continuous tone print. A halftone then is a continuous tone image, what used to be a photographic negative or print, that was converted into an image that was made up of dots. So if you take a magnifying glass, or what's called a loupe, to anything printed, like a newspaper or a magazine or whatever, and you actually look at that through the magnifying glass, you will see a distinct dot pattern. That dot pattern is called a halftone. So let's create a new file and just kind of run through some of the things in that new document dialog box that are relevant to this conversation. What resolution do I need for printed output, halftone output? Well, in order to get a continuous tone image converted into a halftone image, it uses something called a line screen. Without getting too technically deep, it's this element that does the conversion from continuous tone to halftone. It generates a dot pattern. The line screen is what is used in that process. And what line screen gets used is dependent on the paper quality and the printing press that you're going to be using for your project. So you may not know what your line screen is. There's actually some standard defaults and industry defaults here. So for instance, if you're going to newsprint, the type of paper that is used for your daily newspaper, typically your line screen is very low. It's 85 lines per inch, because the paper quality isn't that great. It's very porous. So when ink hits paper, it typically spreads. The term for that is called dot gain. And so the more porous the paper, the harder it is to hold the shape of a very specific dot. So if you had a very high line screen, higher line screens generate smaller dots. Lower line screens generate larger dots. So if we had a really high line screen and you tried to print that on newsprint, what ends up happening is these very tiny dots just bleed into each other and it becomes one big puddle of ink instead of holding the individual dot shapes. So point being, you may not know what line screen you're supposed to be using, but you kind of might hopefully have an idea of what kind of paper you want. Do you want to use a recycled stock, or a matte stock, or a smooth stock, or a glossy stock of paper? Each paper choice you choose will have a recommended range of line screens for the images that will be printed on them. If you have a good relationship with a printer, they'll be able to tell you what line screen you should be using for the particular paper you've chosen for your project. Once you know what that line screen is, great, you double it, and that's the resolution you need your images to be. So let's say that I'm going to be printing a 7x5 or a 5x7 photograph here. And let's say I started out with a resolution of 600 dpi, or pixels per inch. So I'm going to go ahead and type in 600 in the resolution field here. You can see that's a pretty big file. It's 36 megabytes. Now, if my printer tells me, well, you're using a line screen, or we recommend you using a line screen of 100 lines per inch for this halftone project that you're working on, because you're printing on this particular paper, great. What do you do to that number? You double it. So the resolution I need is actually 200, not 600. So if I change this to 200, look what happens to the file size. What used to be a 36 megabyte file now is only 4 megabytes. So the point being is, you may work with really high resolution files during design time in Photoshop, but when you get ready to then to create the derivative file that you're going to be placing in, say, InDesign or Quark or Illustrator or whatever, you're going to take this file and place it and then print it from, it turns out you don't need to send all that extra information. If all I'm going to do is print a 7x5 at 200, I don't need 600 dots per inch of information. So what it does is it keeps your file size down a lot. It takes up less disk space. It actually prints faster because you're sending a lot less information to the printer. And you just have to let go of this notion that higher resolution means you're always going to get a better looking image. For offset printing, that's actually not true. Sending a 200 dot per inch resolution file versus a 600 dot per inch resolution file for a project that's only going to be using a 100 line per inch screen, the images will look identical when you get them off the printing press if you print them side by side. There will be no improvement in quality that you'll be able to perceive by sending the higher resolution file. So keep that in mind. Okay, so that second category is continuous tone output. And typically we think of that as inkjet printing, or it used to be an iris printer, and those kind of gone by the wayside these days. But the inkjet is what most people think of as a continuous tone printing device today. You might have a Canon or an HP or whatever. And the target resolution you need for inkjet printing is never really more than 300 dpi. In fact, most inkjet printers assume a default of 240 dpi. So for example, if you're shooting with a Canon digital camera, Canon also sells digital inkjet printers. The default resolution on the camera, when you capture images digitally with your camera, it sets the resolution of those files to 240 dots per inch. So that when you open up in Photoshop, they've already got the target resolution dialed in. So if you were to print that to a Canon printer, it just already is at that resolution. So the reason you don't need to bother about a line screen is that you're not converting your continuous tone image into a series of halftone dots. You are printing it as if you were simulating creating a photographic print in the darkroom. It is the illusion of continuous tone. If you take a magnifying glass to an inkjet print, it will feel more like a photograph than it will something that you printed on a printing press. You won't see a distinct dot pattern. At least if you have a high quality inkjet printer, you shouldn't see a dot pattern. You should just see continuous tone. So again, I never need more than 300 dpi, provided that I'm printing at actual size, right? So if I want this to be a 7x5 photograph, I size it to be those dimensions. I type in the resolution I need it to be, 300, and that's as much information as I need. You can probably get away with much less. That's why the default is typically 240 for some of these inkjet printers. But again, 300 is just a nice, clean, easy number to remember. Okay, so the third category is outputting to a screen of any size, whether it be an iPhone, an iPad, or a BlackBerry, or more of a tablet computer, or a monitor that maybe you're hooking up to a projector. In that scenario, when you're just targeting a device monitor, a display, you don't actually care about resolution in the typical way we've been talking about it. It doesn't matter what dots per inch the file is set to, the resolution of that file. What matters are the pixel dimensions of the file. And typically you want to target the pixel dimensions of the device or the display that you're going to be representing this image on or displaying this image on. So let's say that I was creating a Keynote or PowerPoint presentation, and I know that I'm targeting my projector, and my projector displays at 1024 by 768 pixels. Great. What you need to do then is change your measurement system in Photoshop, not at inches, but change it to pixels. And then make the width and height of the image the pixel dimensions of the display or the projector that you're going to be hooking it up to. So in this case, I'd make it 1024 for the width, and I'll hit my tab key to jump to the height field and type in 768. Let's say I'm targeting that projector as the image size that I'm going to be displaying here. If it was an iPhone, of course, it would be a much smaller screen size, but you just need to know what the pixel dimensions are of the device that you're targeting. And you can see the file size went down to 2.25 megabytes. Here's what's interesting. Now that your measurement system has been changed to pixels, and I've dialed in some specific pixel dimensions, it doesn't actually matter what number's in the resolution field, because resolution only matters when you print. What dots per inch will the printer use to represent the file when it ends up on paper? If I change this resolution to 1 pixel per inch, I think all of you would agree that that is a low resolution file. The file size did not change. It's still a 2.25 megabyte file, because Photoshop doesn't actually care what the resolution of the file is while you're working on the file in Photoshop. Resolution, again, only matters when you print the file. You're telling the printer what dots per inch to represent the image as it gets printed. So if I change this to 1,000 pixels per inch, again, that you would say that that's a high resolution file, right? But again, the file size did not change. Review halftone output, continuous tone output, or display output. Again, your target resolution, if you're creating halftone projects, is 2 times the line screen. What determines your line screen? The type of paper you're using and the type of printing press it's being printed on. Who's going to know that information? The printer you're working with. They'll tell you what line screen is recommended. You double that number, and that is your target resolution for your final file size. If you're printing to an inkjet printer, it's continuous tone. Your target resolution is never more than 300. And of course, if you're doing a display graphic, a graphic that's going to be represented on a digital display, resolution's irrelevant. All you care about are pixel dimensions. What are the pixel dimensions of the device that you're going to be presenting this image on? Hopefully that clears up what resolution your images need to be.